Children, good morning, all of you. Today for class 12, ISC, CBSE, and West Bengal Board also. Application of derivatives, part 1, that is first lesson. Please pay your attention on the board. First, you have to remember this derivative as a rate measure. Just we have to differentiate, that is dy by dx represent the rate of measure of y with respect to x. We have to differentiate the expression first. Second, if two variables x and y are varying with respect to another variable t, then by chain rule dy by dx equal to dy by dt by dx by dt. That is rate of change of both x and y with respect to t. This you have to remember. If you follow the example, then your idea will be clear. Now pay your attention on the sums given from Abel Agarwal's book, exercise 7.1, sum number 6. Sum you will get in a book, and here also it is written clearly. A balloon which always remains spherical has a variable radius. Solution: let R be the radius of the balloon and V be its volume. Spherical, that is sphere. Volume of the sphere, that is known to you very well. You have learned at class 10. Mensuration, 4 by 3 pi r cube unit cube. Now we have to differentiate this. Differentiating with respect to r, we get, that is dv by dr, 4 by 3 pi, the pi is the constant, and variable, that is r cube, differentiation of r cube, that is 3r square. But radius of balloon, that is given 10 centimeter. 10 centimeter given in our question. The volume increasing with respect to radius when the radius is 10 centimeter. This 10 centimeter is given in our question. Therefore, the rate of change of its volume with respect to t, that is d by dr, in place of r, we have to put the value, that is 10 r square, that is 10 square. By simplifying, we are getting 400 pi. Hence, the volume is changing at the rate of 400 pi centimeter cube by centimeter when the radius is 10 centimeter. Sum is completed. First time you are following. This is why you have to pay your full attention. After looking this type of sum more, then your sense will be more clear. Now another sum. Sum number 12, part 1. A stone is dropped into a quiet lake and waves moves in circles at the speed of 5 centimeter per second. Sum you will get in a book. And now pay your attention on the solution. Let R be the radius of the circular wave and A be the area enclosed by it at any time t. Then area of the circle, pi r square, that is A equal to pi r square. Now differentiating with respect to t, we get dA by dt. Pi is the constant, so it will remain as it is, and variable, that is r square, that is 2r, dr by dt. We are differentiating with respect to t, this is why dr by dt. But dr by dt equal to 5 centimeter per second. That is given in our question. The circle at the speed of 5 centimeter per second, it is moves, given in our question. So therefore dA by dt equal to pi 2r. In place of r, we are putting the in place of dr by dt, we are getting the 5. So in place of dr dt, we are putting the value 5. Then by simplifying, we are getting 10 pi r. Here r equal to 8 centimeter given in our question. When the radius of the circular wave is 8 centimeter, how fast is the closed area increasing? Here radius is given 8 centimeter. Therefore, in place of r, we have to put the value of r 8. By simplifying, it is coming 80 pi. Hence, the enclosed area is increasing at the rate of 80 pi centimeter square by second when the radius of the wave is given 8 centimeter. This is the answer. This type of sum you will get more if you follow attentively. Easily you will understand. But you have to remember the formula on mensuration what you have learned at class 10. Okay, Ishan, Jishnu and others, you must pay your attention, then it will be clear. Okay, thank you everybody.